Today we'll be learning about Hess's law. Hess's law allows the enthalpy change or the change in H for a reaction to be calculated even when it can't be measured directly. And what I mean by that is that all the information needed to acquire the change in H is not provided. If it can't be measured directly, then you have to manipulate chemical equations that are given along with their enthalpies to find a net or final equation. And you basically manipulate by adding, subtracting, multiplying, dividing, and flipping. And I'll explain flipping later on in the video. So keep this in mind. Whatever you do to the equation, you also have to do to its enthalpy. Both of these things are going to be provided in a problem. Say you have this equation here. Ethane plus 5 oxygen yields to 8 water molecules plus 3 carbon dioxide. Then if you multiply the equation by 2, then you also have to multiply the change in H by 2. So since you're multiplying this by 2, you multiply this by 2. And your final answer for the change in H here is going to be negative 4,440.2. Okay, so when you flip an equation, you basically take the products and you bring them to the left side of the yields to symbol, and you also take the reactants and bring them to the right side of the yields to symbol. For example, say you have the equation here, 2 water plus 3 carbon dioxide yields to ethane and 5 oxygen. But the problem asks you to put C3H8 on the other side of this symbol here, which is the yields to symbol. So what you would do is you would flip the equation. So what's in red would end up on the right side of the yields to symbol, and then what's here in black would end up on the left side, and this would be your final flipped equation. So it goes from this to this. Okay, so again, with manipulation, whenever you flip an equation, you have to change the sign of the enthalpy, or the change in H, which is provided along with that equation. So if the change in H of the equation is positive, then you have to switch the sign so that it's negative. And if the change in H for the equation is negative, then you have to change it so that it's positive. So we're finally to the problem. They ask us to calculate the change in H, or the enthalpy, for the following equation. 3 carbon plus 4 hydrogen yields to ethane, or C3H8. And they provide us with these 3 equations here, along with their enthalpies. Okay. So basically they want us to manipulate each equation that they gave us so that we can get this final or net equation here. So what you're going to do first is multiply this here, which was the original equation that they gave us. You're going to multiply it by 2 because we need H2 in the final equation, and this first equation that they gave us is the only one that has H2. See, none of the other ones have H2. So because there's 4, we have to multiply it by 2. And again, remember, if you do something to the equation, you also have to do it to the enthalpy change. So you multiply the enthalpy by 2 and also the equation, and you get this here. Okay, second thing, we're looking at the second equation, And you see that C3H8 is on the right side of the yields to symbol. But here in the equation given, it's on the left side of the yields to symbol. So what you're going to have to do is flip it. So C3H8 plus 5O2 is going to end up on the right side here. And this here is going to end up on the left side. Since you flip the equation, you have to change the symbol. So it goes from negative 2,220.1 to positive 2,220.1 kilojoules. The final equation that they gave us, you're going to have to multiply the whole thing and its enthalpy by 3. Because if you can see here, there's carbon in the net equation, and this last equation provided is the only one that has carbon. If you can see, these two don't have carbon. So you multiply it by 3, this whole thing by 3, and you get 3 carbons plus 3 oxygens equals 3 carbon dioxides. And then when you multiply the enthalpy change by 3, you get negative 1,180.5 kilojoules. Okay, so basically to get your final answer, you have to see what's on opposite sides of the yields to symbol, and you got to cancel them out. You see, like, start with H2, 4H2O, I mean. It's on the right side here, but it's on the left here, so those are going to cancel. If you add 2 oxygens and you add these 3 O2, they're on the same side of the bar, so you can add those. It gives you 5. And then on the right side, you see there's 5 O2, so you can cancel all 3 of these oxygens. And then finally, you have carbon dioxide. There's 3 carbon dioxides on the right side, and there's 3 carbon dioxides on the left, so those cancel out. You're left with 3 carbons, 4 hydrogens, and it yields to the ethane here, which is the only 3 things left over. You bring those down. This is your final equation, or the equation that they wanted in the beginning. And then you're going to add all 3 of these enthalpies here. And you're going to get negative 103.8. Alright, so that's it. I hope this video helped you out. Thank you.